welcome everyone to today's ALASCA Tech Talk. We have Tech Talk number 15 today of the Tech Talk series that we started at the beginning of last year. As always, please take notice that the session will be recorded. And as usual, you can find the videos on YouTube afterwards to watch it again, or in case you want to forward it to someone who you think might be interested, then the video will be there in a few days. My name is Maria. I'm with Cloud and Heat Technologies, and I always moderate, or almost always moderate, these Tech Talks. So for those of you who see me for the first time, I'm happy that you're here. And let's get started with today's session. Oh, sorry, we have no spoiler. Sorry. 1 second, I have some trouble here with the screen sharing. So you should be seeing the agenda right now for today's session. It's just always a very short agenda. We will start with Tech Talk of today, which is around 25 minutes long. Then we have some time for a discussion. And then I will show you some news and events where we have some great news and some events that we like to share today. So sorry for that small spoiler. We will have some more time to look at it afterwards. So I would just like to briefly introduce our speakers for today. And the topic of our Tech Talk. So we will be looking today at internet infrastructure, and the Tech Talk of today will be based on, or we focused on the internet exchange points, and then we will hear some more about specific internet exchange points, a project that was founded recently, the Dresden Internet Exchange. And to present this very interesting topic, we have two speakers today with us. So we have Matthias Wählisch, who's a professor at the Technical University of Dresden, and as you see here in this this summary of his CV, he's quite an expert in internet communication, where his research and teaching is focused. He's the chair of distributed and networked systems at the university, and well, he's been actively involved in several projects and several communities related to open source projects and internet in general, and is one of the co-founders of the Dresden Internet Exchange. And we also have the Tassilo Tanneberger, who's also one of the founders of the Dresden Internet Exchange Point. He's there's an Internet Exchange project. He's a student of computer sciences at the Technical University of Dresden. And well, you see here some of the topics that he's interested in related to routing security, new language models, time-sensitive cyber physical systems. So also quite a background. And without further ado, I will hand over the microphone to both of you, Matthias and Tassilo. Stop my screen sharing, and you can start whenever you're ready. Oh, we have some issues. Oh, Zoom died. They will be right back. Okay. So let's wait a couple of minutes to see if this gets sorted out. Otherwise, I think what I can do while they try to connect again is I can do the events and news now, and then we will have the talk afterwards, so that we give them a couple of minutes to try to reconnect. Anyway, I already showed you some of the things that are coming up, so I will do that now. Then let's have a couple of minutes to sort out this technical issue. Okay. So I think you're seeing my slides again. So let me just share some news of the ALASCA Association while we wait for our speakers to be back. The first thing is we have great news. If you've been following our LinkedIn channels, then you probably have already seen this news. But Krake, one of the projects of the Alaska Association, is nominated for the Saxony Digital Prize 2024. So this is a huge milestone for Krake. This nomination is in the category open source. So we're really happy that that Krake got selected. There are three nominated projects in this category, and yeah, it's a huge opportunity for this project. And you can find here some links or some calls for action. There's a video that was filmed a couple of weeks ago and is now live, where you can watch, see some more information about Krake. It's a really nice video. And the voting is open until the 30th of April. So please vote for Krake. You have the link here. I can post it in the chat afterwards. And we're really happy when if you can support this this project, and spread the word. So just share it with anyone who you think might be interested and might find this this project a nice project to vote for. So that's one of the things. Matthias, Tassilo, I'm just starting with the events and news. So to give you some time to reconnect, I'll just do one more slide and then I will hand over to you, right?
Perfect.
Okay, perfect. Thanks. And then also two events that we wanted to inform about or to remind you about. There's the ALASCA Summit that's going to take place in Dresden at the end of October. And the call for contributions and the call for sponsors is open now until the end of April too. So the 30th of April is where all the deadlines are going to be for the voting of the digital prize, also for this summit. So if you have any ideas, you want to get involved, you want to share some ideas that you have for presentations or for workshops, then please submit it to us. There's a form on the website that you can just fill in. It's very short, and send us your ideas. And then also from the Alaska community, we have some news. So Stackit is organizing their CloudX Summit, which will take place in Heilbronn in June. And they also have a call for contributions, which is open until April 30. So please also take a look at that and see if there's any things that you want to submit to get involved in that event too. So one voting to call for contributions, all deadlines April 30. So we're in the countdown for all of those. Yeah, so just take a look at that as soon as you can. And with this, I'm done with the news and events. So now I will hand it over back to Matthias and Tassilo. I hope that the connection works now.
Yes, I hope so too. Thank you, Maria. Sorry for the hassle. You try everything advanced and rehearse, and then it doesn't work anyhow. So let's start. This is Tassilo. That's me, Matthias. And today we want to talk about a very important thing. It's called the internet. And want to give you a brief background on how the internet works and how you can actually improve your internet connectivity by making use of a so-called internet exchange point, which we founded here recently in Dresden. So when the talk is structured into parts, I will give you the background, and then Tassilo will present the most recent updates on the DD-IX, the Dresden Internet Exchange Point, that aims for keeping internet traffic local. So what is the internet? Usually the internet is thought as a cloud, but it's not really true. The internet is not a single network. The internet is a network of networks that interconnects at the end people with machines, people with each other, and also machines with machines. So if you think about the services that run on top of the internet, there's a plethora of services, and there's actually nothing nowadays that runs without the internet. And at the end, it's all about connectivity, connecting people, us, with some kind of services. And the internet is the underlying infrastructure that enables exactly this, that provides this type of connectivity. And in contrast to many other networks, that the internet is a global network, and that is application independent. So it is not tailored to a specific service, but enables almost any service, and provides some kind of abstraction to do this. So, how does it work in detail? It's similar like in real life. If you want to send a letter, for example, to someone, you need to have an address to which you send the letter. In the internet, these addresses are called IP addresses, Internet Protocol addresses. There are some numbers. You see an example for an IPv4 address. There are also IPv6 addresses, which looks a little bit more cumbersome. Now, to enable this connectivity, what the internet needs to do is to actually forward a packet that has also a destination address and needs to find a path at the end. And what you can do is, in the most easiest way, is to flood this packet to all your neighbors inside the internet, and these neighbors flood the packet further to their neighbors, and so on and so on. But this is not a scalable approach, obviously, in particular, if you consider that we currently have more than 80,000 of these clouds, of these autonomous systems, of these networks, and many, many more end devices, so billions of end devices. And if you would flood every packet that this end device transmits, you would have a lot of congestion, and the network would be overloaded. So what would be nice is to have some kind of information inside the network that steers the path that the packet needs to go. And then you can think about how do you store this type of information. And one option is that each node inside this network remembers all of the potential destination addresses. This, on the other hand, is also not a scalable approach, considering the number of addresses that you currently have. Would cost a lot of memory inside your network. So what you do is that you start to aggregate these different IP addresses to so-called prefixes, and the prefix covers a set of IP addresses. For example, here this prefix 212.111.0/24 means that it includes all IP addresses from 212, 111, 245.1 to 212, 111, 245, 255. And in this case, each component in this internet only needs to remember this aggregated prefixes instead of all more detailed, more specific addresses. Now we have an approach how to remember potential destinations in a scalable way. And the next step is that these components inside the internet called routers announce these addresses, these aggregated addresses, to their neighbors, such that any network inside the internet knows at least one path towards these aggregated prefixes, the destinations. So if a packet comes in, the router knows what is the next hop to forward is towards the destination. And for this, each router maintains some kind of data structure that includes the addresses and the next hops. And the router also decides on the actual path that is taken. In our example, we see that we have multiple paths towards the destination, and at the end, only a single path needs to be taken. It's similar with the letter in the real post system. The letter goes exactly one route towards the actual destination. And now it's the question, how do you decide on this path that is taken, and how do you announce these addresses in a scalable way? And scalable means also in an automatic way. And there is one protocol that implements exactly this. This is a so-called border gateway protocol, or short BGP. And BGP at the end enables these networks, these autonomous systems, to exchange this prefix information. On the one hand, on the other hand, it enables the network operator to define individual policies that allows on the path that is taken. So on the preferred path, If then later a link, for example, breaks, it will automatically discover an alternative path towards the destination that complies with the previously configured BGP policies. If you want to be part of the internet, what you have to do is either you ask an operator that this operator gives you some kind of IP addresses, or you run your own network, you run your own autonomous system. And if you run your own autonomous system, then obviously you are much more independent on the path that is chosen, for example, and also on the connectivity level. And why is this independence nice? Basically, it also saves some money and might also improve the performance. Now, the question is, which path do you choose if you have multiple options? Usually, the selected path is driven, or the policy is driven by two criteria. One is that the costs are low, and second, that the latency is low, right? I mean, and latency is a very important aspect if you think about what improved and fostered innovation in the last decades in the internet. Then were technologies that actually reduced latency, so the time until the packet is delivered to the destination. And in our example here, the router on the right-hand corner has two options to choose a path from the server to the destination. The upper path doesn't cost anything and has a low latency because the networks are directly connected. The lower path costs something because this operator pays someone else to enable the connectivity, and it has a higher latency because it traverses more than one autonomous system. Obviously, I mean, you would most likely choose the top path because it's free and it provides better latency. And by BGP, you can actually configure exactly this. Now, we know how to announce and distribute these addresses, how we choose or why we choose specific paths. Now, the next question is, where do we actually exchange these packets? So these routers or the network operators need to meet somewhere to interconnect and to hand over the packet from one network to the other. And there you have two options. You do it privately or connect to a so-called transit provider that provides you a connectivity to the internet. The alternative option is that you meet at a public so-called internet exchange point, or short IXP, where other networks are also there and wait for networks to peer with to exchange the data. This is usually that exchange points are usually run as an association, which means that the fees that you have to pay to get the connectivity to the other networks at the IXP are very, very low, much lower compared to a cost that you pay for the transit provider. And the main idea of IXPs is to bring the local networks together and as such keep the local traffic local instead of spreading it around. And this basically leads to reduced cost and obviously latency because you are on site already with your next peer. To illustrate what is the disadvantage if you don't use an IXP and rely completely on third-party networks, I brought you this little example here. That is a measurement study that we did a couple of years ago in Berlin, where we explored which passes were taken if networks that are located in the same city. And this example here, Berlin. And what we found is that if you wanted to, for example, access a website of the Berlin city from a DSL network inside Berlin, then the path that was taken is from Berlin to Hanover, to Frankfurt, and from Frankfurt back to Berlin. This is obviously a little bit nuts. And if you would have used an IXP as a Berlin Internet Exchange point, then the traffic would have been completely local. So you would have reached the website by only traversing a network that is inside the city. So Without an IXP, you give up control, and most likely you will extend your paths with an IXP. And by peering its IXP on your own, you have control and you can exchange the traffic directly, locally with your fellow peers. From a more technical point of view, an IXP looks like this. An IXP provides you a switching infrastructure where you can connect your BGP router, your network, to interconnect with the other peers. As you have to establish BGP sessions to do this exchange of routing information, the IXP provides a service so-called route server that simplifies this. So instead of connecting to every peer separately, you would connect only to the route server that maintains the BGP session for you to all other peers. So an IXP is a switching infrastructure route server, and what is also important is some kind of a community, so where you can meet your peers, other networks, and exchange also, I don't know, lessons learned from running a network, for example. And when you look around, then you will find that Dresden doesn't have an, or had an IXP for a long time, and considering that Dresden and the region of Saxony is a quite lively region with a lot of tech companies, lots of research institutes, and also strong student environment where you have a lot of potential internet users. We thought that it would be quite beneficial to found such an IXP here in Dresden to improve the internet ecosystem and actually to implement a little bit a more modern internet connectivity here. And now I hand over to Tassilo, who will give you some background onto the DD-IX.
Yeah, so we very recently founded Dresden Internet Exchange. We initially came up with the idea around 2020 when we explored, what is possible, how do other people do it, and after meeting and a lot of people, we then assembled a team in June 2023, and then our journey started. One of the first things, and also a thing that happened very quickly, was that we also got our AS number, AS 57328, which was sponsored by DD-IX. A couple of months later, we also now have this association, not by German standards. It's not an association that has the public interest in mind, but a general association. And then we plan to start operations later next month. And now I want to talk a bit about so Matthias talked a bit about how internet exchanges work generally, and I want to talk a little bit how our deployment looks right now. And our switching infrastructure works on the Arista 75SX. It's a little bit older model, but it still supports 10G and 40G SFP+. And as Matthias already told, an internet exchange is conceptually just a big LAN. But because we have different locations where we are present, aka points of presence, one at city center, which is near Hauptbahnhof, and one in Koschitz, we need to span this LAN over multiple locations, and the technology we use for that is EVPN VXLAN. EVPN is an extension of BGP to transport those the discovered MAC addresses to the other locations, and VXLAN is located on the data plane where that's how you transport them or wrap those packages and transport them to the different locations, the actual data packages from the customer. To connect those two sites, we use ISIS as IBGP. Okay, so we established how our peering LAN looks like, but now we still want to supply root servers because letting every peer connect to each other peer requires a lot of overhead. And there we have a small, we borrowed from eBay hard doors. They are quite, in a sense, not very powerful boxes, but they also don't need to be. And we run as a root server, we run Bird, which runs on those 2 different locations. And of course, we have multiple root servers for just redundancy purposes. And to those, Bird servers, then our peers can connect. But then there's a last thing missing, and that's our peers. And our initial peers are a good mix of ISPs, so internet service providers, which actually connect customers, and also, content provider, for example, TU Dresden or Cloud and Heat, or ISPs. But eBay Hard does a bit of both. They as well do hosting, but also connect customers as well as DC. But an internet exchange is a lot more than just having switching infrastructure and running root servers, because there's a lot of infrastructure behind the infrastructure that keeps things running. And this ranges from very classical things like you need to monitor your infrastructure, but also to very human things like we need to communicate with customers, wiki of some cloud so people who actually, for example, do the finances can work. So the amount of work that, for example, that goes into actually running the IXP and running the infrastructure behind the IXP is roughly 50-50. And what we do is this main server runs mainly on NixOS with Astro. Astro is a person from Cyprus that built a very nice wrapper for VMs. And so we have a lot of infrastructure in behind powered on the single machine. And so the question is, we are just voluntary. So it is very important that the infrastructure runs without a lot of supervision. And for that, we developed, the development is done. We developed a quite fully automatic deployment scheme. So maybe to run you through a little bit here. So we have the IXP manager, you can see in the left right corner, is an open source tool developed by different stakeholders all over the world for which is the customer view of the IXP. There you can enter their MAC addresses for security purposes, their names, which port they're connected to, and so on. And this is a source of a lot of information that we then use to generate configs. And our main config builder is some reasonably large Ansible role, which aggregates all the information from the different sources, like taking the MAC addresses, the ports, takes static configuration from the repository and aggregates them. And it also starts this root server. This root server is a program that allows you to generate Bird configs. Bird is the routing daemon, and so we fetched those configs, and then we parsed them all together and then deployed them to our different infrastructures. For example, the switches, the root servers, but also monitoring tooling like this S-Flow exporter. And this happens every 6 hours. So if you do a change in our customer portal, this after at least 6 hours, the servers will come by, fetch your data, and update all the machines. And the most important thing is because the users enter data, you want to do input sanitation, and you want to validate them that this thing that was entered actually fits our requirements, so nobody can try to maliciously inject any configuration onto our machines. So this is really important, and we spend a lot of time doing validation and sanitizing all the inputs, so there's no potential security risk running this automatically, rolling out user information. And maybe zooming now a little bit out, our whole deployment looks roughly like this. We have 2 switches with connecting our peers. We have on each switch there's a connected root server, and then we have all the extra infrastructure that is then connected to one that is in the data center in Košice. And this is quite a good starting point, but we have more ideas of what we want to do. For example, something that no real, or as far as I know, no other internet exchange does right now is, for example, validating end-to-end of deployments. So if I change the config, do I actually in 6 hours get the desired result, and do I can measure it, and do I can say, yes, this deployment went back to back and didn't silently fail somewhere on the way. And I think that we also don't have yet is, for example, a lab setup for automatic validation, so that we can push our config, for example, onto our lab, automatically validate it there, does it work, and then deploy it on the running infrastructure. But okay, so I talked a lot about how does our deployment look, but what is as equally important, and Matthias already mentioned it, is the people behind it. And the big point here is that you have all this nice infrastructure, but if you have nobody that's interested in using it, you have no customers, you have no people who maintain it, it's useless at the end. So we founded this association for it, and this association is it has very similar goals to ALASCA. It tries to do education, it tries an outreach, but compared to ALASCA, we constrain ourselves to Dresden and Saxony. Compared to and ALASCA tries to, it has the scope of Europe. And we also do a lot of open source development. I just skipped over the slide there. But ALASCA, it's the main purpose to develop independent cloud open source projects, and our goal is bringing the local community together and collaboratively maintaining this IXP. And the prices are roughly similar for individuals and companies. And we are very interested in aggregating a very diverse range of stakeholders. From we need companies, we need companies, we need operators, we need individuals. So this is a very healthy mix, because it's a core infrastructure that supports the local community. So having the different stakeholders that then can express their opinion is a very critical part. And there's a good there's a very good opportunity to join this community, and that is our open tech meetup that we will do in the start of May, on the 7th of May, where a lot of local companies and interested individuals will meet up in this room, and we will a little bit more discuss in more detail what we did, what we have built, what are our plans, and try to then foster this local community. And so I encourage you very strongly to consider joining us there. It's if you're operating a network, if you're operating some service, please be here, because it is if there's not enough local support for the project, it will at some point die. And so it's very, very important for us to get this going and get critical mass. And with that, I'm just quickly, so Matthias and IBH and also DD-IX great supporters in our efforts so far. And just want to say thanks to them. And with that, I want to conclude our talk. This QR code leads to our newsletter. So if you're interested, you can also find it on the webpage, and there's our website and contact email. And with that, I want to thank for their attention.
Great. Thank you very much for your presentation and for sharing with us your experiences with the foundation of this new association. And yeah, it was very interesting what you were presenting also to see the parallels with ALASCA. We also went through a similar process with the foundation of the association. So yeah, there's a lot that I can relate to, or we can relate to. So with this, there's now time for questions and discussions. So either raise your hand or just unmute yourself and ask the question, or you can also paste them in the chat, and then we will read them out loud, and so that Matthias and Tassilo can answer them.
I mean, we also did some research in it before and checked how many potential autonomous systems are already here present in Dresden. And we were a little bit surprised, I must say. The number is quite low.
Negatively.
Negatively surprised. There is also a little hint that some of you want to get involved in this business here and run. Think about running your own network instead of only relying on third parties.
Yeah, it's a little bit of a horrible state that, half of the packets go to Frankfurt. Yeah, and
instead of being local. And we all should not forget, I think that the internet is a community project, and I think that's also where we and ALASCA nicely align. And the community means that we also need to work together. So now we have some questions here in the chat.
I would read them loud out. Why is the validation always done in a 6-hour time window? Is there a performance reason why this is not done in an hourly cycle, for example? So you really don't want to. So the problem is, okay, first idea would be for if you would build a system like this. Okay, if the user input changes, let's automatically trigger a redeployment. But this is, for example, a horrible idea, because then people just start entering stuff, and if they're have malicious intent, you will start triggering redeployments every so often, and it's somewhat good. So you can say we want to increase it or not with trade-offs, but the main trade-off I see between decreasing the period versus increasing is that if failures happen, you have a little bit more time to respond. If so, every 1 hour, would mean that your changes would go in immediately. And if there's problems, for example, I don't know, the switches stop working. We really don't want, or parts of the generation of the config are not working. We don't want that. We maybe see that one redeployment changes something, stuff breaks, and then we have roughly, we can stop the redeployment process and have roughly 6 hours to fix stuff. Julian Völsch is writing, or did this answer your question, or?
Yeah, thank you.
Do you have any special pricing for non-profits? You only mentioned individuals and corporations. I think we currently don't have them. No.
But I would say just talk to us. As Tassilo said, we try to be very inclusive, and also you saw the member fees are pretty low for the individuals, I mean, we try to support also non-profit people and organizations. So I think we will find a way that it's not an issue.
Yeah, but maybe a note on that. We make the deliberate decision to only natural people have voting rights. This is a deliberate decision to we want to avoid the potential trouble of corporations with all corporations have monetary interests, but we are mainly interested in maintaining a good quality infrastructure, and I think the people should be interested in that. Of course, our corporations are interested, but we really don't want that. The monetary interests are, inflicting too much our day-to-day operations or our society, the decisions of the association. So
why did you choose?
Yeah. So why did we choose Ansible for automation? Did you compare different solutions? We thought about other solutions, but so what we were interested in was so technically what you want is a script. So you want a script that redeploys your services. So at the end, the program you're building needs to be a script. And right now our script is automatically triggered by some systemd timer on that server. But we also, if we have made manual configs, we want to be able to roll them out also. And we also thought about, for example, running our root service with NixOS, but we reasonably quickly realized that that NixOS isn't as a Linux distribution isn't ripe enough yet to do those things. So our root servers right now run Alpine Linux, which then gets deployed with Ansible, and so and this Ansible, it basically doesn't do anything else than validation and templating out the configuration files. And for that, I think Ansible is, I also have my problems with this Turing complete YAML, but for this purpose, it was more than acceptable.
And it is not uncommon, I must say.
Yeah.
I know a lot of network operators who use this as well. Yeah. So, but long story short, it was an informed decision. So it was not by accident. We evaluated other options, but decided for this.
Yeah, and we are running, I don't know, this unholy alliance. Some people would regard it as, we are running, I don't know, Ansible inside an XVM. It's quite uncommon deployment, but it has its benefits and it works rather well for us right now.
Other questions?
Okay. That's a thank you. Oh, great, from Silvio. So here, are there any other questions or comments?
René, Rico, do you have and/or see any potential strategy within the decentralized internet, more broadly speaking, e.g., when it comes to offering and settling on relevant resources such as storage, bandwidth, and compute?
I mean, honestly, the IXPs, IXP helps to keep the internet decentralized at the end, right? Because instead of relying on transit providers, the peers connect directly with each other. And what we currently face in the internet is some kind of consolidation towards few stakeholders. And this is true for actually all layers of the internet stack. And personally, I would say that the IXP is a fundamental building block to prevent this type of consolidation and keeps the internet really decentralized and also democratized, if you like so. Regarding compute and storage bandwidth, I mean, the idea of the IXP is not to provide this type of service, but to provide a connectivity infrastructure for autonomous systems, for networks that provides, for example, additional storage and compute capacity, and to keep the base very short to get access to these additional services. for example, when you want to upload files to an external computer infrastructure, that you do not need to traverse multiple autonomous systems, but can directly transfer it to your next neighbor that provides this service.
Yeah, but yeah. So if you're interested, I think you hold a talk on last DD-IX. And last DD-IX, how was the talk titled?
Something is decentralized.
Yeah. But you can, if you look up, I think it's, so the DD-IX recordings go online on mediaccc.de. And there is a talk from Matthias right about the topic of
decentralized internet, and that was a study actually that we did for the Federal Office of Information Security, the BSI, where we explored this topic in much more detail and also measured aspects of this. And one conclusion at the end was also XP is a pivotal point for keeping the internet open, decentralized, and also deconsolidized, actually. Okay, hopefully this answered your question.
What did you miss in Nexus? So there were a couple of problems which we also fixed in XOS, and that's, for example, the initial. So when we started looking into it, if the system D unit that NixOS generated didn't have reload functionality, so every time, so we basically build a test VM, and every time we updated this test VM, our bird would restart, all the BGP sessions would go down the drain, and they would need it to be reestablished. I think we already fixed that again. But at that point, we already wanted to get going, and Alpine Linux has in some sense very similar functionality that you can. It's not as declarative as NixOS, but you still can describe, like, I need this and this packages and so on. And that's what we are right now using. So the problem was mainly that, if you do your rebuild, you really don't want the bird to restart, and this initially getting this, when this atomic rollover happens, there was some uncertainty if everything still works. But it's something that we probably will explore in the future. And right now, but we have this big management box that I think there was also on the screen, and there's all the Nix configs and so on are all publicly available in our GitHub. So if you're interested, you definitely can take a look at it. And I think I also just skipped over the slides. The open source slides. So we did also do a lot of Nix packaging for all the surrounding infrastructure, like this root server, which builds bird configs, or this IXP manager. And this is all publicly available. And if you're interested, I know, in spinning up your own internet exchange, you're very welcome to use these configurations.
Yeah, but in another city.
In another city.
Okay.
Yeah,
Okay.
and maybe. Yeah. Okay.
No, go say
No,
you want to add something to it. Yeah, no problem.
All fine.
Okay. So I just wanted to launch the last call for the final questions.
Then
Oh, another one.
Yes, another one. With the background of Matthias, are there any plans to do more with the RIPE in the context of internet measurements, like to provide a vantage point etc.?
Yeah. I mean, what we probably could do is to add a RIPE. So for those, I mean, RIPE is an organization that manages the address space for Europe and Eastern Europe, and RIPE is also doing a lot for the internet community. Yeah, it's a very nice organization, including doing measurement and provide measurement and also analysis of the measurement to keep the internet healthy. And one important project of VIBE is the VIBE Atlas, which is a little Raspberry Pi box that you can connect to your network and such that other people can run measurements on top of this. And I think what we will do is, for example, to connect one of the VIBE boxes, Atlas boxes, to the DD-IX to have this type of additional vantage point. And if RIPE is interested, they also have passive route collectors that collect BGP updates. And if they're interested to peer with us, we would also definitely do this. So, yeah.
Yeah, we are generally very happy if you have measurement projects. We are very happy to connect them. Or general like those. There's a lot of different, you know, good projects. Like if you look at our website, there's, for example, AS112 already peering with us as the reverse DNS sync. So
yeah, we will
good projects we support.
And I mean, on the other hand, we will also take advantage actually of the in-house knowledge of doing sound measurements to improve the operation of the DD-IX, by the way. So this is definitely also something that will happen.
Thank you.
Okay. So if there are any more questions, just space them or unmute yourself. Otherwise, yes, please. I would also like to support Matthias and Tassilo's call to support the project and join and get involved, because with these projects that are very democratic and sort of open, I guess that's the key point, to have a lot of people contributing to it and supporting it in multiple ways. So yeah, it's a really nice association. It's a really interesting project, and I think with value for the community. So yeah, go for it.
Yes, let's internet rock together in Dresden and Saxony, I would say.
Yeah, great. Okay, so I think I don't see any more questions. So I would like to thank you both very much for your presentation, for being here with us today and sharing your knowledge and your experience with us, and also to thank everyone that joined the discussion. And yeah, with this, if you could stop sharing your screen, I would like just to one more slide share. Well, the first thing, if you will just allow me, I would like to make a small correction, because Tassilo, I saw that in my first slides, your name, I don't know, it wasn't correct, your last name. So I would just like to make that right. Sorry for that. I don't know where that came from. Sorry, so I think I said Tassilo Tanneberger, but it's Tassilo Tanneberger.
Yeah,
so
that N goes in there. A lot of people insert that N. All good.
yeah. Okay, so sorry, I just realized where you were speaking and I thought, no, this has to be corrected. So that's the first thing I wanted to say. Then I am going to post in the chat the link to the voting for the digital prize Saxony for Krake, if any of you have time to vote for that, and you can take a look at the rest of the projects. So there's a lot of interesting projects there. And I wanted also to just show you what's coming up in the next Tech Talk, which will be in the last day of May. Friday, May 31st. So we have a talk by Miguel Caballer from the Polytechnic University of Valencia, and he's going to present the Infrastructure Manager, which is a tool, an open source tool that uses Tosca for orchestration and for deployment. And we've had some talks that have already mentioned this project related to Krake, or the last talk with AI Sprint, where some of these tools that were developed in the project were presented. So that's a deep dive into this Infrastructure Manager. And unfortunately, I will not be here to moderate the talk, but I have found a replacement. So Matthias from D-Nation, which you also know maybe from other Tech Talks which he moderated, will be here with you on the 31st of May. So I hope that many of you can join the next Tech Talk. And with this, thank you again, Matthias and Tassilo, and thank you to the rest of you. And I hope that you have a very nice weekend, and that we will see each other in the next Tech Talks.